Okay, stats. We're in the second half, or the like as the last two examples of 7.2. We're talking about population means and estimating population means. And yesterday we were talking about creating your confidence interval, which should look something like this, where you're trying to estimate the population mean mu, and trying to find those two values on either side based on your error. Okay, so we calculated error, and the formula for error was just this guy. You take either your z or t value and you multiply by s over the square root of n, and then you add and subtract that from your x bar, and that will give you your two numbers that mu lives in between. Okay, so now what we're going to do is in example 4, we're going to kind of work backwards like we did one of these in example in section 7.1, where they're saying, okay, if I want my error to be this much, how many people do I have to survey? Like, how hard do I have to work if I want this much error or whatever? So, like, do I have to go out and ask 100 people? Do I have to ask 1,000 people? Like, what do I have to do here? So that's what we're going to be solving for here. So in the error formula, we had like z times s over the square root of n. Sometimes they'll use t in this place instead. Okay, and we'll talk about that. But if we're trying to solve for n, right, like we're working backwards, so we're going to divide by z, and then we're going to flip-flop these two, and then we're going to square, and we're going to do all the things. And so they went ahead and wrote it to look like this. Okay, now z is your critical number, and they are not using the t chart. They are using the z chart. Okay, and here is why. Okay, the z chart is the one that's just on that positive, and it's like down in the corner here, right? And so if you're using like 90% confidence, you'll use like 1.645, and 95 is 1.96, and all the things, right? Okay, so you'll use those numbers. The reason why you don't use the t chart is because in order to look up and find the critical number from the t chart, I have to know degrees of freedom, and your degrees of freedom is 1 less than your n, right? So like if n was 15, I would use 14 degrees of freedom, okay? But here I don't know what n is, so I can't even use the t chart. So when you're solving for n, you're always going to use z as your critical number in order to find n. Okay, and that's why, is because you don't know what n is to find your degrees of freedom. So here what we're going to do is we're taking z times sigma, which is your standard deviation, and then we're dividing by the error, and we're squaring, and that will just tell us what our n has to be. Okay, so assume that we want to estimate the mean IQ score for the population of statistics students. How many statistics students, that means we're solving for n, must be randomly selected for IQ tests if we want a 95% confidence interval. That tells me that z is, I think if you look up on the chart, it's 1.96 for 95%. And the sample mean is within 3 IQ points. Okay, now that means my error is 3. When we did when we did proportions, like percentages, and they said like 3%, that meant 3%, which means my error was 0.03. This is just saying 3 IQ points. So we don't have to convert it from a decimal or from a percent to a decimal. Your error is just going to be 3 when I plug it in. Okay, so I'm going to plug it in here, and I'm solving for n, and I do this big long thing that I'm going to end up squaring. Okay, I'm taking z times the standard deviation, and I'm dividing by the error. Okay, what's my standard deviation? Oh shoot, I can remember this from last year. They don't give me a standard deviation, and that was a typo. I remember this, but I don't remember what the standard deviation is, and I don't have my book in front of me. Let's make up something. They have to give you a standard deviation, otherwise you're just SOL. 3 is my error. I know that this is 1.96. Let's go with standard deviation of, I don't know. Let's say your IQ standard deviation is 20 points. I don't know. Does that sound right? 20 points for a standard deviation for IQ? I don't know. We'll go with it. Okay. So if the standard deviation is 20, and again, they have to give you that. That was my bad for a typo. I'm going to multiply those together. So I take 1.96. I'm going to multiply by 20. I'm going to divide by 3, and then I'm going to square that number. And if I square it, I get n equals 170.7. And it doesn't matter what this decimal is, no matter what, I always have to round up, even if that was a 1. So I have to survey 171 people in order to have an error of 3. I should look up, what is the standard deviation of IQ? Because I feel like it should be higher than that. What is the standard deviation for IQ scores? Oh, they say 15 points. Okay. All right. Whatever. Yeah. I don't know. The mean IQ score for the entire population is 100 and the standard deviation is 15. Okay. Whatever. Well, we did 20. So we have to survey 171 people in order to get an error of 3 on either side of my population average. Okay. All right. So there's that. Now, part 2 is talking about, and I put this little chart down here. So put this down here at the bottom. And this is better for me to explain than this little yellow sheet. So if you want to replace this, here we go. Just write this down. You know sigma, which is your standard deviation, or you don't know your standard deviation. Okay. And that is not just any old standard deviation. That is your population standard deviation. Okay. So if you know your population standard deviation, you will always be using the Z-chart, regardless of whether n is greater than 30 and n is less than or equal to 30. Now, yesterday, I think I told Reese, I told you that the equal to sign went with this one. The equal to sign actually goes with less than 30. I looked that up, and so that was wrong. So I'm sorry. Less than or equal to 30. Greater than 30 is greater than. So inclusive here, not inclusive here. There you go. But if you know your population standard deviation, you're using the Z-chart no matter what. If you don't know the population standard deviation and your n is less than 30, you're going to use less than or equal to 30, you're going to use T. If it's greater than 30, you get to use Z. Now, most of the time, it says up here in like this little box that I had you like cross off. In reality, you rarely know the population standard deviation, because if I knew information about the population, then why would I be creating a confidence interval in the first place, right? Like I would just know that information, okay? So rarely does this happen. And a lot of times we're going to end up with samples that are smaller, so we're going to use the T-chart. Rarely does that happen, but it does. So we're going to do an example like that on part 2. Okay, so here we go. If you need to pause to copy that table down, go for it. Here we go. Use the same 15 birth weights of girls given in example 2, where the number of girls that I had, girl weights that I had, were 15. The average of those girls' weights are 30.9 Hg, like hectograms or whatever. 95% confidence interval is what I want, which means the Z that I'm going to use, because I want to use Z in this case. I know that my population standard deviation is 2.9, not just the standard deviation for my sample. I think the standard deviation for my sample here was, the sample standard deviation was 2.9. So the population standard deviation is the same as the sample standard deviation. But we know from the entire population that their standard deviation is 2.9, okay? Which usually we don't know that, but they're saying that we know it this time. That is how I know that we get to use the Z-chart, okay? And the Z-chart for 95% is 1.96. So I need to find my error, which is Z times sigma over the square root of n. Just the same formula. So 1.96 goes for Z. 2.9 goes here. The square root of 15 goes here. Okay, again, I don't need the degrees of freedom or anything like that because I'm not looking up on the T-chart. I'm on the Z side, okay? And, oh gosh. Let's see what I get. 2.9 divided by times. Okay, I get 1.47 as my error, okay? And that's the error. We need to add and subtract him from something, okay? And we're trying to estimate and find the confidence interval for mu, okay? Now, mu is the mean, and so is x bar. X bar is the mean for the sample, mu is the mean for the population. So I'm going to take and add and subtract the 1.47 from the 30.9. So my interval is going to go 32.37, and if I subtract, I don't know, it's like 29.43, I think, something like that. Okay, so we can say that the population average weight for these baby girls will be somewhere between those two numbers. Okay, and that's a fairly narrow window, right? Slightly different than the population than this range that we got because we used the T chart there. Okay, whatever. T was like, I guess, yeah, 2.145 was the T value that I used in my equation, versus here I got to use Z as 1.47. No, 1.96 for my Z. So there's that. I don't know. I could go further into the whole Z and T. Like, Z is a normal distribution. And so typically when you know your standard deviation, you have a normally distributed data set. And so that's why you get to use the Z values instead of the T values. I could get more into that, but that's maybe for another day. Okay? All right, so not too much today, but you should be able to do most of this homework assignment, actually. If you get stuck and you don't know what you're doing, just start like dissecting the paragraph. Like, fill in n equals 172. Oh, hey, look at that. My n is larger than 30. I can probably use the T chart, or excuse me, the Z chart, because n is larger than 30. So that is that 95% confidence interval, 1.96. I can use the Z chart. My X bar is 31.8 with a standard deviation of 7.4. Are the results very different from, okay, so they give me that information. We need to find the confidence interval, and then they say, is that very different? Meaning, do the two intervals overlap or do they not overlap? If I have this, which was results from only 17 samples with an X bar of this and a S of this, we don't care about this information. We're only looking at this interval in comparison to the interval that I'm going to create here. Okay, but they're saying that this interval was the information that I got when I only sampled 17 people, right? I want to know if the interval when I do more work and sample 172, is that going to be a completely different interval? Can I get away with just doing 17 as a sample? Is this interval close to what it actually should be with the 172? That's kind of what they're asking. Okay, and so again, they're asking, like, do the intervals overlap? Or are they completely off from one another? Okay, all right, so go through that, do as best you can through those problems, dissect out the information, put variables with them, and you're just calculating your error and adding, subtracting, and finding your confidence interval. So do the best you can. You can work together if you want to, I don't care, but try to work through those 8 problems. Okay, goodbye.